Okay, so quick review. We did what north and south poles are on magnets, like how to draw field lines. This little one where you're supposed to, this is really what the Earth looks like. The North Pole of the Earth is really a south pole because north poles of magnets point toward it, so it must be a south pole. We went over this right-hand rule, and did I talk about electrons in here? I might have skipped over this. I circled it, so I must have talked about it. So this is just saying, like things like this, these are just hard pieces of plastic. They're not magnetic. They don't stick together. They do have moving charges in them, but those moving charges, those electrons that are in there have opposite spins, so they cancel one another out. And even if I put this next to a really powerful magnet, it doesn't stick. But if I put iron next to a powerful magnet, it becomes magnetized because in iron there are unpaired electrons that are going the same, that can line up and have the same spin. And magnetism is all about the motion of charges on a small level. So we did this, and this solenoid, you can use a solenoid to make a speaker. I made a speaker yesterday. I took some of this 22 gauge wire here and I wrapped it carefully around magnets sticking all over the place. Wrapped it carefully around this. This was the thing that the magnet came in. So now I don't have a safe container to put my magnet in anymore. I'm going to set my magnet out. Whoops. How'd that happen? Okay. So put my magnet in like this. There. And the way this is set up, I've got two alligator clips connected to it. I've got my red one. Red usually is associated with what, isn't that, that's so annoying. Everything wants to stick to this magnet. It's too bad I don't have some aluminum or copper alligator clips. Dang. So anyway, the red one's still connected. God. Gotta put those. So tired of that. It's rolling around, it's being attracted to things in my desk. And now you lost sight of it again. Hell. So I'm gonna connect the black to this. I just want to do a nice little demonstration, that's all. Alright, so black is connected to that, red's connected to this, and notice that the red, this is the wire that goes up the near side, and it goes around and around and around and around. So if I connect the red to the positive terminal of a battery, I don't know if this is a good battery or a bad one, but it's probably good enough. You know what I need? I need to zoom out. That way I don't have to have things closer than they need to be. So the red is going to go to the positive, and in just a little while I'm going to connect the black end to the negative, and that's going to turn this coil into an electromagnet. And if it's so current's going to go through this side, through the near side, around and around and around. So which end of this electromagnet is the North Pole? Get out your right hand.
With the magnet?
Get out your right hand and stick your thumb in the direction, your right thumb in the direction of this current right here on the near side. And then once you imagine aligning your thumb with this current on the near side, stick your fingers through the center of the tube and tell me, are they pointing to our right or to our left? They should be pointing to the left. So if, just modeling it with this, the current's going like this, round and around. If I do this and I stick my fingers through, they should be going to the left. So where's the north pole of this electromagnet? Right or left? Left. All right. So we're going to use that knowledge to figure out which pole of this magnet is which. I'm going to connect it, and then I want you to tell me, like, this pole that I'm patting right here with my finger, is it the north or is it the south? Here we go. Is that the north pole or is that the south pole? Ah! God. Here we go.
That's the north.
It's the north. So if current's going in like this, and the magnetic field of this solenoid is to the left, that means that's the north pole of this electromagnet. So what kind of a pole would it be attracted to, a north or a south? So that means this is the south pole because they're attracted. If I stick that south pole right in there, they're gonna get attracted. Now, what happens if I do it the other way? It's more fun. So now I'm going to put it in there and connect it, and they're going to repel. So, I need longer wires. So this is a motor. It is essentially a motor. It's just a really simple motor. It doesn't give you rotary motion, but it definitely gives you motion.
How can you shoot it if you like aim it up?
How what?
How can you shoot it if you aim it up? Like
The cup?
No, like aim the cup the other way so it's like facing upwards, like a cannon or something.
Well, I'll do this and see if it shoots out of my hand. Yeah. So there's that. That wasn't really like why I made this thing. So what did I say this was? Speaker. So how do I get it to speak? No, I'm not going to talk to it. Uh-oh. Olivia, you might end up being in my video. I'll try to avoid putting you in my video. Let's see. Having rotating issues. No. I just can't. Why can't I turn this? It's that cord, isn't it? Ah, there we go. All right. I'm almost there. Nobody's going to watch this video anyway. Except maybe people in India.
People in India watch your videos?
Yes.
Huh.
No, that's good. I don't know why I said it like that. All right. So I'm going to take this over here.
You should do a shout out.
My second most popular video is how to restore toolbars in Rhino, which is a CAD program. And there are a lot of people who I think are in India who thank me for that. So I'm going to play some music, and it works well if you play some bass, something with bass. So think of something with good bass in it. I'm doing Seven Nation Army since nobody came up with anything. So here's what it sounds like on my phone. It's not playing.
Can you do 500 pounds on 1 second?
500 pounds. That sounds like not something I should do.
No, it is.
No, it's not bad. What about National Treasure by Drake?
And Spotify's picked this moment to not work.
It's not.
Everything else sucks.
Not true. I'm not a huge fan of that album, but that's not true.
You're a glazer, but you're making an edit of it.
I just did a circle.
No, I'm making it out of Anthony Edwards. That's the song that I'm using. It's National Treasure.
Okay.
Okay.
So there it is on my phone. And then here it is on the speakers. And then I'm going to switch it to speaker B, which I have connected to this. And this is, I think, just the right speaker. So songs that have different things going on different tracks.
Okay, I fucked it up. Shh.
now, but it doesn't do anything until I put it near the magnet. Here, Olivia, hold the magnet. Don't get it real close to anything metal. And here, put the cup over it.
Yeah.
How does Bluetooth work?
I don't know about Bluetooth.
Yeah, I actually don't get that. How does Bluetooth work?
It's starting to get hot, so let me turn it off for a second.
Yo,
Um,
bro, what's your drinking spot?
So here's something else you can do with. There's some other tricks with this, but I want to make sure I practice before I end up screwing things up. So I've got one of the bulb bases and a little bulb. And I'm going to turn the volume down.
In one place.
And then connect this to the bulb base. What's going to happen? Anybody? If the bulb is good, something should happen.
It's gonna light up.
Maybe I should crank it up.
Light bulb.
Really?
Well, present them.
Maybe that's a bad bulb. I blew out a bulb on purpose earlier. I'll use one of the ones I blew out.
This area, good one, dude.
No. I think you got it. Columbia.
Song's going to be over soon.
Well, you could just restart it.
That's true.
What?
Oh, I turned the speaker off.
Oh my.
That's why it wasn't working. Okay, let me turn this down, turn the speaker on. Okay, now I've got, it'll take a second to click in, but should have speaker B.
No. Dude.
What the heck? It worked great before. Anyway, it's supposed to just be
Thingies.
glowing.
Stomach shape.
Huh. Maybe I messed up the bulb base? Or maybe I just keep choosing bad bulbs?
I thought that was for me.
What is it
I
on?
think you should stop putting your hands in your pockets while you walk, man. I think you should not do that. Can you stop drawing on me? I'm not
What if that's a
built
worse
in this
space?
to be artist. I think you're drawing on me.
Oh,
You're scratching me.
it went into protect mode.
So it didn't blow up.
I don't know why it's not.
Well, then why'd you give it to me?
I don't know.
You were like
Huh.
exhausted.
I don't know. I don't know why I can't blow out the bulb this time.
Is it hot?
No, these big wires shouldn't be hot. I'll see if the speaker's still working. I wonder if there's just something that I messed up with the output.
C H R L.
That's still working. Huh. I don't know why. The bulb should light up.
Why can't you just use yours? Well, maybe I could have used
And it should light up to the music.
Oh, that's really cool.
You do.
All that walking over there and turning the thing to nothing. Okay, so I want to get to a point where you'll understand motors. So here's the new right-hand rule. We're not going to do Lenz's law next. Lenz's law is the last thing, and that's the really hard one, the really mind-blowing one. This is the right-hand rule with current, magnetic field, and force coming out your palm. So let's try a few of these that we didn't do yesterday. First, just a little magnet field line drawing practice. Here are two magnets. They're stuck together. Label the remaining 3 poles. Each magnet has 2 poles. See if you can do that in this picture. So what's this pole?
South.
South. How do we know it's south? Sticking to that one. And this pole? North, because it's opposite that, and so that's how those two will stick together. Now, this is showing what happens to a metal thing when you put a magnet nearby. So this is a magnet like this one, and this is a guitar string like we're going to be using with the electric guitars. And when you put the magnet in the presence of this wire here becomes a magnet. So if that wire is turning into a magnet, which pole of this magnet is on top? North. So it's going to be north like that, south like that. So it turns into a little magnet, and later when we get to Lenz's law, we'll talk about how that moving magnet creates electric current. We already did this and this. Let's do this one. So this requires all 3 parts of your hand, your palm and your fingers and your thumb. So the current's going through a wire like this. The magnet is right there. Is this wire going to, which direction is this wire going to be pushed? And the answer is either going to be into the paper or out of the paper. So get out your hand, your right hand, and what part of your hand do you need to point rightward? Your thumb. And the magnet tells us which way to point what part, your palm or your fingers? Your fingers. So which way do you point your fingers? Down, because the field is like this. It's out the north side, so there's B. So you point your fingers down and your thumb to the right.
I don't even know how to do it.
And if this is hard, what you can do is sometimes it helps to flip the paper. Then it might be easier. So now if you're doing your right thumb, you point it to the left and you point your fingers straight ahead. Is that easier? Yeah, so which way is my palm pointing when I do that? Down. So what's the symbol for into the paper? X's. So this would be, the X's represent the force. So that wire is going to get pushed into the paper. Okay, now we've got 2 different variables. Here, the dots are the magnetic field. If they're dots, which way are they going? Out of the paper. And the wire is being pushed up and to the left. You have to figure out which way the charge is going. Charge is your thumb. Force is your palm. The field is your fingers. Up and to the right, you think? Do people agree?
So is it like this?
So stick your fingers straight into the paper and stick your palm that way. I've got to zoom out in order to do this. I'm sticking my fingers into the paper, but my palm needs to be this way. And which way is my thumb pointing? Up and to the right. So Ethan was right. So this is the direction of current. Palm is the force. Now, another one. We've got current going through a wire to the right, and the wire is being pushed down. Which way is the field? Yeah. Oh, wait. Yes, sorry. These are out, not in. I'm getting mixed up by the like the convention. I have a hard time with this, remembering the dots are out. So really I should be sticking my fingers out and, whoa, let me do this back up here. So fingers are coming out, palm is going that way, so that means my thumb is going like this. So yeah, Ethan's right again. So it's going to be down and to the left because these are coming out. Whew. Be careful about that. This is the kind of thing where you have to stay calm and think about it carefully. So what's the direction of the magnetic field here? Don't screw this up. I'm not going to screw it up either. I'm going to be really careful. Hudson, close that. You should practice. Try it. I should see everybody with their hands out. Right hand. You could put your left hand in, like, on the table or somewhere. You could amputate it. You don't need it. Sorry, Colleen. All right. So which direction is the magnetic field here?
Into the paper.
I hear into. I haven't done it myself, so I don't know. It is into the paper? All right. So I need to point my thumb to the right, and I need to point my palm this way. So I think this might be a situation where
Flip your paper.
I can either flip my paper. I can do this. I can point my palm back at me, so my palm's going this way, and my thumb's going to the right. And to do this, my fingers have to come straight out. So if I flip my paper, is that easier? Sort of. My thumb still needs to go now to my left. My palm needs to go there, and my fingers are sticking straight out. And out is what? X's or dots? X's are into it. There's no good reason why it's one and not the other. It's just they had to decide on something. So this is the field. So now here's graduation. We're going to watch a little video about electric motors in just a second. Which way? So this is one way to make a motor. The way I made it earlier on in class is another way, but this is a coil of wire, and it's coated with enamel. The ends have been stripped off so that there's just bare copper there and there, and it's touching these posts, which are made out of aluminum, and they're connected to alligator clips, which go to the battery, and underneath there's a magnet. So the first question is, which way is the current going to go through this coil? Is it going to go clockwise or counterclockwise? Is that right? So which side of the battery does current come out of? Positive. So current comes out here. It goes in over here. If you follow it, and you follow it through this post and into the coil, is it going clockwise? Counterclockwise. So it goes up here, goes into the coil like this. So along the top of the coil, the current's going to the left, and along the bottom of the coil, the current's going to the right. And then it comes out over here and then goes back to the motor, or back to the battery. So which way does the top of the coil get pushed? So we're looking for force on the top of the coil. The question ultimately is, if you look along the left end, do you see this whole thing rotate clockwise or counterclockwise? So is this going to get pushed away from us or pulled toward us? So what part of your hand needs to go leftward?
Your thumb.
Your thumb. And then what part of your hand is dictated by this?
Your fingers.
Your fingers. Which way do they need to point?
Away. Up. Wait. No.
Up or away? Which way is the magnetic field? Into north or out of north?
Out of north.
So the magnetic field is this way. That's the magnetic field. And that's the way what needs to point? Your fingers. So you point your fingers straight up and your thumb to the left. Which way is your palm pointing? Like that. So the top is going to get pushed away. Now let's see what happens in the bottom. At the bottom of the coil, the current goes to the right. So what part needs to go to the right? What part of your hand?
Your thumb.
Your thumb. So my thumb goes to the right. My fingers need to point up. So my palm is going toward us. So the top is going to get pushed away from us. The bottom's going to get pulled toward us. And if you're looking down this side, which way is it going to go? Clockwise or counterclockwise? If it's going like this. Yeah, if you're looking from over here, you're going to see counterclockwise. So the answer is counterclockwise. All right, try this one. The torque is clockwise. So if you're looking from over here, this is going to rotate clockwise from this standpoint. Figure out which terminal of the battery is the positive one. Let's see if you can think through all these steps. And if you can't, you've got a 50-50 chance. Either the right is positive or the left is positive. Okay. Has anybody got it? Which terminal do you think is positive? The left one? Let's check this. So if you look from over here and the torque is clockwise, that means it's, well, clockwise is like this, right? So if you're looking down in here, clockwise means the bottom is coming out toward us and the top is going away from us. So if I just draw the force here is into the paper and the force here is out of the paper. So here it's going away, here it's coming toward us. That's just like, that's what this means. So if I want to make the force going away from us up there, that's the way I need to point what? My palm. And the other part of my hand that I know what to do with is my fingers, because they're dictated by this. So which way do my fingers need to point? Down, because the field is down. So if you point your palm away and your fingers down, which way is your thumb pointing? So palm is away. I have to be a contortionist for this. I'm going to turn my paper. There. My palm is pointing that way, and my fingers are pointing into it. And see my thumb? It's going out this way. So if your palm is pointed that way, and your fingers are pointed this way, then your right thumb has to be pointed like this. So this is the direction of current along the top of the coil. And if that's the direction of current along the top of the coil, then the current's going clockwise. So which end is it going to come out of the coil? Left or right? It's going to come out over here. So the current is going like this, and it's going in like that. So which one of these terminals is positive? The right one. So these are 50-50. But it's hard to get a whole sequence of these right. So now, sit back and enjoy a video which